Okay, things are about to start here, but we'll wait a few minutes for stragglers to come in. Of course, we will mock them mercilessly as they tumble through the door, but we will wait for them. I sure hope the coffee holds up. Otherwise, I'll have to switch to Coke.
What kind of Coke are you talking about, Tom?
The solid kind.
Yeah, most of it have our mic muted, so you can't tell if a joke lands.
Yeah, that's the funny part. Yeah, I know. Wah, wah, wah. It's okay. And really, and this is something that's kind of important here to understand. This whole thing is very informal. So, I mean, if you want to go ahead and keep your mics open, and if you have a question, ask a question. Uh, there's no formal process here. I will adapt to the room, and this is as much for everybody else's benefit. This isn't for me. This is mainly to get what's in my head out to all of you, but also to try and get the wheel spinning for everybody involved. So, it's whatever. We'll see how it goes here. And I have no issues if people want to take and connect on 2 or more devices so that they can stay connected. So we're good there. How many are we up to now? Oh, we have 11 people waiting in the window. Oh, okay. Wow. Admit everybody. Okay, how many people are we up to now? Wow.
I would guess nearly 20, certainly more than 15 if you had 8 people waiting.
Yep. There we go. Yeah, up to 20 at least. And
now it's a party.
Yeah.
Hello.
Hello. And yeah, as I was telling everybody else here, just if you want to speak, just speak. You don't have to raise your hand or anything. This is totally informal, and I will take and adapt to the room. This is not this isn't a lecture. This is just me trying to share what's happening here and to listen to all of you guys and get feedback from all of you guys and to try and get some wheels spinning, hopefully.
Are you using any emulators for your development, Tom?
Yes, I am. You can see right here, actually, we have a copy of Altera running in this window right here, and it is attached to a FujiNet PC instance that I have running right here. So I actually have not only have FujiNet in hardware form, but we have it in software form as well. And this could go for other systems as well if we could figure out how to take and hook this to other emulators and other device systems, such as ColM for Atom support and, MAME or stuff, whatever, but the option is there. And even if we have to take and move FujiNet off of the ESP32 platform onto other microcontrollers, we can do it pretty easily. So yes, I am using emulators.
Okay, so you're using it for the Atari, but are you using anything for the Atom? Is it?
No, the Atom is a real Atom. There is no emulator with FujiNet support for the Atom, so I am using a real Atom here. For those that are interested, it's actually connected up via RetroTink 2X Pro that I have connected to an Elgato HD60S Plus, providing HDMI capture. And you can see I'm literally using it as a camera right here, so you guys can see its screen. All right, well, as people tumble in, we'll take and admit them, but I think we're, oh, wow, okay, more, okay, wow, all right. Admit everybody. If we see more people, I will try to keep my eye on the admittance here. I want to see if we can hit the 50 limit here, just for the hell of it. Okay. Hey, Bill.
Good morning.
Hey, as I've mentioned before to everybody coming in, this is completely informal. If you have a question, if you want to say something, just say it. I will adapt to the room appropriately. This is not a lecture, so this is extremely informal. And if it seems like I'm winging it, it's because I am. So may the wind take us where it wants to go.
Hey, good evening.
Yep.
At least here in Germany.
Okay. Looks like we've got a nice selection of people who decided to show up. This is fantastic. Thank you all for coming. Really, seriously, from the bottom of my heart. I hope you guys find this enjoyable. So without any further ado, let's get started. What is going to be covered in this particular talk is essentially how to take, first and foremost, is how to take and adapt an existing game to use FujiNet. And for the sake of brevity, and so we don't bore people to death, I won't be typing things in, but rather showing you functionally differences between two sets of the programs and what essentially is added. Essentially to try and get rid of as much dead time as we possibly can, if that makes sense. So what we'll be covering is a version, first off, and this may actually turn out to be quicker than the rest of the meeting, and if so, we'll take and dive into a lot of other topics as well, but we'll talk about Connect 4. I chose Connect 4 because it's a very simple game with very simple rules that could be adapted quite easily to something that to a network protocol that could be used for turn-by-turn play. So we'll start. If you guys want to follow, if any of you guys want to follow along, the program is available on TNFS for each of the different systems here. For the Atom, it's on Atom Apps in the Games folder. As FujiNet Connect 4, we can go ahead and literally quick boot that. And for the Atari, it's on Atari Apps in Games as Connect 4. I need to get rid of that other one. And we'll go ahead and boot. Now to prove the point here, the Atom version is written in C, while the Atari version is written in TurboBasic-XL. So it doesn't really matter which language you want to use for writing FujiNet games. What matters is, A, can you talk to the FujiNet? And B, what protocol are you going to agree on to send messages back and forth? So we can basically go ahead and I will, as a matter of demonstration, I will set up the Atom here and tell it to listen for a connection. Now, this basically means that right now the Atom is acting as a server. It's listening for TCP connections and it's accepting them on port 6502 TCP. So all I have to do from the other side is essentially give my name here and connect to the host name on the other end. And what it did at that particular moment was it went ahead and sent the player name over to the other machine. So the Atari sends its player name over to the Atom sends its player name over to the Atari, and both listen for the other's input and synchronize that way. And at this particular point, now it's Tom's turn. So the Atom goes first. And you can see as I move my cursor, it's updating on the Atari side as well. And all it's basically sending on the over the network is what row am I currently at? And when I drop a piece, there's a special row set aside to indicate that a piece has been dropped. The game continues, goes to the next person, and you can see now I'm moving on the Atari. The Atom is moving appropriately. We'll take and drop a piece there. We'll just make this a really quick, dumb game. And you can see we're bouncing back and forth. And because in this case, since we're going with turn-based moves, and because when we're waiting for input to come across, the input is blocking, that's acting as a synchronization mechanism to try to keep everything in sync. So now when I take and drop the piece on the Atom, since both sides are essentially doing rule checking, they have to because they're peer-to-peer, they both figure out that the game has been won and we can choose to continue again or go on. To go down a little further, we'll take and move this guy out of the way for a moment. And we will open up a little terminal window. And we will use a little tool that you can grab called netcat, which is absolutely indispensable for diagnosing network connections. And we're going to set up a listening socket here on port 6502. I'm going to wait here for a moment while I'm going to go ahead. Oh, sorry. Looks like we got more people coming in. And if I admit, yes, go ahead. I will look over there in the waiting room eventually, I promise. I'm sorry for you guys that have been straggling in. Oh, Peter. You guys are late. Okay, so as I was saying, we have a listening socket working over here on the left window, and I'm going to reset my Atom to come back in and boot back into Connect 4 from here. And this time I'm going to be the client. I'm going to talk to the netcat instance that's over here on the left window. You'll see that we waited for a connection received. It sent the player name. We can respond. And once we do, the game has essentially started. It is now waiting for my turn to do something. I can't move my cursor keys over here on the Atom because it's waiting for something to happen over here on this side. Not a problem. I'll put in a row. And as I put in the individual rows and in the line, it processes the line and you can see what happens across. Now, if I take and use the special row 10, it will drop the piece. Conversely, now that the Atom is actually in control here, you can see that as we move the cursor across, we're basically just sending over the current row as telemetry. I go ahead and drop the piece, and you can see that the special row is hit. And the process continues over and over and over again until the game is actually won. And again, since all the rules checking is done on both machines here, because this is peer-to-peer, we don't have to specify any of that in the protocol at all. It keeps the protocol simple, it keeps it understandable, and at least for the purposes of what we're doing here, you can see how this will be adapted into the game. Well, that ends this particular portion of it. We'll go ahead and close this off for a moment. And we'll reopen a listening connection here while I go over to the Atari side of things. And we will set up a little miniature environment here to do some experimenting with. Now, as some of you have seen, I'm using an Atari emulator, Altera. Altera is kind of special because it has the ability to deal with custom devices. We can go into configure system. We can go into devices and we can see that there's a custom device called NetSIO. And I have a copy of NetSIO, which is connecting to a FujiNet PC instance, which is providing my FujiNet. It also has the ability here to provide really, really beneficial debugging output. Conversely, on real FujiNet hardware, you can use the FujiNet flasher and the serial debug output button here to get extremely valuable debugging information from a real FujiNet as well, if you don't want to do the whole board bring up. If you do, we can talk about that later. So put this to the side here for a moment, and I will go ahead and cold start the computer here, which will reset the virtual FujiNet. And in fact, what I'm actually going to do, since I don't need the window to be that big for this, I'm going to shrink you down a little bit. And I'm going to try to maximize some space here as much as I possibly can. And
sorry, Tom.
Go
I'm trying to log in from my laptop now that I'm back home.
Mhm.
Would you mind letting me in so that
Oh,
I
yeah,
can
yeah,
get to this one?
Oh my God, yes,
Thank
there's people. Yes, yes, there you go.
Thank you.
Hey, we've got a lot of people showing up. This is absolutely fantastic. This is awesome. Okay. So now I'm going to go ahead and I'm going to go over here to my local SD card slot storage here. I'm going to make a new disk and we're going to call it boom, make a standard 90K disk, nothing special. We're going to put it over here, but we're going to go over to Atari apps. And there is a DOS folder here. And in this folder, there are versions of different Atari DOSes, all with the in handler ready to go. Let's just pick one. Doesn't matter. Boom. Put that in drive slot 1. And if we see we have our DOS disk in drive 1, our new blank disk in drive 2 here, and we'll just boot. you can see that basic prompt, we go to the DOS real quick. And we will I2, Y, H2, and you'll find all sorts of interesting things on these DOS disks here. FujiNet tools of every shape and size so that you can use all of the FujiNet functions from inside your DOS of choice. But here we want to use the in handler. So let's go ahead and copy it over into a usable state. You can copy indev over to drive 2, and you would name it something like autorun.sys for most DOSes, or for my DOS, it's autorun AR0, AR1, whatever order you want it to boot into. And that's all we really need to do to set up a little scratch pad here that uses the in handler. We'll go ahead and cold start again, go back into FujiNet real quick. We'll flip things around a little bit. I'm doing it visually like this so you guys can see me actually doing this rather than me pushing a disk swap button to take and flip this around. We'll mount it as read write here, and we'll boot into it. So now we have our in device. This is all we need to do to really get it to work. And we can test and make sure it's there if we do something like this. Okay, good. If we were to get an error 130, that would mean that the handler's not loaded and that something would be, and that you needed to load the driver. We know that the driver is loaded. Now, to start off with some of the basics in the in handler here, how do we make a connection? Well, it's pretty easy, actually. All we need to do is open a channel. And if you're used to doing input and output on the standard Atari IO, all the same rules apply. So for read and write, that's 12. And you specify the second parameter becomes a translation mode. 0 is no translation. 1 is translate carriage returns to end of line. 2 is translate line feeds. And 3 is translate carriage return line feed pairs. So we have our URL. In this case, we're going to talk to a TCP connection sitting over here in this window. Port 6502. And you'll see that the moment that we did that, we get the connection received over here. Great. And at this point, we can now send stuff across. How do we send something across? Like that. How do we receive something? Like this. Make sure we have a variable to hold it. That's all we absolutely need to do to send information back and forth. And the nice thing is because this is completely compatible with BASIC or any other program that uses the end device, we can send back big bits and pieces of compound information as well by separating them with commas, just like you would in a standard file. Just like that. So using this from BASIC is absolutely as simple as it can possibly be. This is quite intentional because one of the use cases for this was literally so that people could write network applications, network games, or whatever as part of the 10-line BASIC contest. When we're done with the connection, all we really have to do is close it. And you'll see that the netcat realizes that the connection is closed and everything is as it should be. So does anybody have any questions so far?
Yeah. Hi, Thomas.
Hi.
I have a question. Regarding your host name, do you have own local DNS server? Because you are using TMA2 host.
My router picks up MDNS broadcasts as well as DHCP host names and provides a local name server for it.
Okay. Okay. Thanks.
Any other questions? There's absolutely nothing stopping you if you don't have host names to use the IP addresses if you have to.
Hey, Thomas.
Hey.
Hey, how's it going? So in Altera with the virtual end device, how do you push the buttons, the physical buttons that are on the FujiNet? Is there a menu for that?
There is currently no facility for that yet. Got to figure that out. So essentially, what that means is you can't push the disk swap button. It's not. We just haven't figured out a way to expose that yet. We'll probably have to work with Avery to take and add to be able to take and add something to the drop-down menus, etc. Probably in the input here somewhere. We'll see.
Hey, when I use the
Thomas, not exactly, because when you open a web application, a web connection to the FujiNet PC device, there is a possibility to push soft buttons there.
Okay.
So
Yeah,
this is possible to open a web browser and connect to FujiNet PC.
Yes.
And there are options to push buttons.
Essentially, you're saying we could probably add it here. Or sorry, wrong. It's running local. It's localhost. There we go.
That's right.
Add it here somewhere. Okay. Yep, we could definitely do that. All right. So
Can I ask a question, Thomas? I'm sorry.
go ahead.
And please forgive me if I ask a stupid question. I'm sure everybody here has a lot more experience.
Questions, just ask. It's okay.
But if I wanted to do this with an emulated system, is there a ready-made image, let's say, of an Atari that with the emulator inside and configured with FujiNet, so I could play with this just for writing, some game or something?
Jan is actually the developer of FujiNet PC is actually working on that solution. So you will be able to soon enough.
Okay.
So that's, yeah.
We have also translated documentation. I did it 2 weeks ago.
Okay.
So it was published on the Discord server and also on Facebook.
Okay. And speaking of documentation, that's actually a wonderful segue here. If we go to the FujiNet website, which is fujinet.online here, and we go into the wiki, boink, we can see all sorts of documentation that we have been putting together, talking about how to use the end device and the different things like programming the commands you can use with the end device, some cheat sheets, etc. So like say, for example, you've got how to use the end device as a user to take and load software. Since we have the end handler here, we can do crazy things like loading software from web server or directly from an FTP site or from an SSH site. Doesn't really matter. It's just lots of interesting examples here. You also have valuable programming information so that you know, for example, the different types of commands that you can send to the network device to do different things. The end handler that we've built for the Atari makes it easy to use the FujiNet from inside BASIC. But if you're writing something in assembler or C or another high-level language like Action, it might actually be easier to use the SIO directly on the Atari, in which case you get plenty of examples in the documentation on how to take and set up the various SIO calls and how to do them. And as well as links to the different auxiliary values that you can use. And so on. Lots of great documentation here. And this is definitely for the Atari side. And as we bring this over to other platforms, I'm looking for help from other people in these other platforms as well to try and help me take and write the documentation for the other platforms, Atom, Apple II, Commodore 64, S100, etc. And hopefully we can take and branch this off quite nicely. Finally, I'll mention here that we have something of a Rosetta Stone for doing FujiNet programming here, which we've implemented. The NC program that you saw me use in some of the other windows in various different languages on different platforms. This is all you need to implement netcat using the end handler in Atari Basic. That's it. Conversely, there is a C version over here in CC65. Norman Davie did a wonderful job taking and translating that into an assembler example for Atari assembler with tons of documentation inside of it. It's wonderful. Lots of documentation. There's a version for Action as well. So you can see all the differences. Things like doing the SIO calls, setting them up, the main program. And the most recent example, which I did, showing that you could use the Coleco Atom from inside CPM with Microsoft Basic, since the AtomNet is actually memory mapped. You just have to write to the appropriate addresses to do the appropriate operations. And the actual netcat program is up here. So let's see. what else can we do here? So with that, I think we can actually start diving into looking at the Connect 4 example here. So on the Atari, since it was written in TurboBasic-XL, K-Savitz actually turned me onto a wonderful little program called Turbine, which allows you to write your basic Excel code in a text file on your cross machine. And it will take and parse it and turn it into a highly compressed TurboBasic program in as few lines as humanly possible, basically crunching each line as much as it possibly can. And with that, I think that's his secret to submitting stuff to the 10-liner basic contest. Most of what we have to do really concerns ourselves with just sending over the player information at the correct time and getting it when we need it. The first major difference here that you'll see, we enter opponent name and not, is that now on the FujiNet version, we add an additional section here for entering a host name, getting that host name, and listening for a connection. Now you'll see here that there's no host name inside the N URL here for the connection here. If you do not provide one to the TCP connection, it's assuming, oh, you want me to listen for a connection. And I can actually demonstrate that for you now. If we still have our little scratch pad up here, and if we open up a connection, say I want to listen for connections on port 6502, we'll keep the debug window over here. So, oh, wait a minute. So where are you? Wrong one. Excuse me just a moment. Let me find my FujiNet PC window. If we open up the connection, you'll see in just a few moments. Oops, sorry. You'll see that it is now binding to port 6502. Bam, okay. And at this particular moment, if we then take and try to connect, hopefully this will work. I'm kind of improvising here with FujiNet PC. We'll see what happens. Oh wait, there's, I'll here. Can't do it with FujiNet PC because I have no way to connect to it. Never mind. I'm so sorry. It's behind a virtual NAT and there's no way for me to connect to it. But I will go ahead and do the commands anyway. At this point, we have a listening socket set up. It's going to sit and allow for a single connection to come in, and it'll be placed in a bit of a waiting room. We still have to accept the connection. Speaking
Thomas,
yes.
can you open up another end port, just open number 2, and then on the Atari talk to itself through different channels? So you could demonstrate it entirely in the Altera by having 2 connections open to the FujiNet. I'm just asking if you could, because then you could test it all on the Atari.
No, because of the way the virtual network's set up. Oops. And this is my bad here. But I'll go ahead and go through the motions anyway. at which point we can take and accept a connection using XIO. And once that actually happens, this will error out. But yeah, see, it's waiting for a connection that won't happen. But once that happens, you then have the input and output channels connected, and then you can send stuff across. So with that, that's essentially accepting a connection. Pulling it in, great. So host name empty, we accept the connection, at which point we check to see if there's a connection waiting. And if there's a connection waiting, then this location 748 will return 1, meaning that there's a connection waiting, at which point we take and do the accept. And IO channel 1 is now ready for sending information back and forth. We take and get their name, we send ours. And we make a little flag here indicating that host is now player 0. Otherwise, if there is a host name in here, we connect to it. We build up the host name here using the same rules as before. In TCP, the host name, port 6502. We mention that we're connecting to it, and all we have to do is open it. If this command completes successfully, then our connection is open and we can immediately start sending to it. We take and send our name, we wait for theirs, and we indicate that we are now the other player. Connected, okay, great, some sound effects. Then we take and draw the board, get all of that board's bits and pieces set up, and so on. Draw all the little circles for the board, etc. And at this point, then we fall into an infinite loop unless broken. So we go ahead and check for tie games if we've laid down 57 pieces, because we're going ahead and counting each piece that comes across. Otherwise, we figure out whose turn it is, display that. Come down here, do a little color setting. And we deal with our 2 main chunks of our loop here. If it's the local player's turn, then we go ahead and we send a starting position so that the opposing player knows as quickly as possible that where we actually are. Quick feedback is good feedback. And we wait for the trigger to be pressed. And while the trigger's not pressed, we figure out whether we're going left or right, figure it out, take and impose the constraint checking that we need. And finally, we go ahead and send the position. When we push the trigger, we take and send the 10, which is our dropped piece. If the column's already full, then we error out. Now this is a potential error here. We could have potentially taken move this down and do the checking for this first, then send the drop if it's possible. So who knows? Again, this is a point of contention, but whatever. Otherwise, opponent's turn, and we wait for bytes to come in. 746 on the in handler gives us the number of bytes waiting, and if there's something waiting for us to input, then we grab it. This is important because inputs with the in handler are blocking. They will block until something comes in. So if you're wanting to process other things, you want to do a status to check for whether or not something's actually available. And there is no timeout, so it will wait indefinitely for data to come in. And if it's a direction move, then we do the appropriate, then we place the piece appropriately. We do it in this manner here because the piece is actually implemented as a player sprite. Otherwise, we take and branch out. If they press the trigger, we do a column check. Okay, great. If that's okay, then we indicate that the piece has been dropped down here somewhere. Whee. And we keep doing this over and over and over until somebody wins. And this is actually an important point of contention here. Because this is peer-to-peer, because there's no server that's handling the game rules, this essentially means that the rules checking has to happen on both sides of the game. And it's important, and this is why it's important if you're writing peer-to-peer games, to get the game logic working correctly first before you insert any logic to take and try to send moves over to another player across the network. And that's all we really have to do for the Atari side of things. Now let's show on the Atom side of things to see some of the differences. Any questions so far? Am I making sense? Okay, so I'm not making sense.
No, it's good. It's showing up in the chat. You're just not seeing it.
Oh, what's oh, sorry. Yeah, sorry, I probably don't have the chat window open. So if you want to say something, literally say it. It's okay. You're not going to be rude. I'm explicitly inviting interruptions because I view interruptions as beneficial, because it means I'm not addressing something or something else needs to be addressed. Where is that chat window? See, now I got to find that chat window. Somehow I've lost the chat window. I am so sorry.
Your share screen usually floats around your computer. It's confusing in Zoom. So it might be next to, it's next to your share screen button.
Okay. Yeah, good so far. Okay, absolutely making sense. Okay, good. Yes. Okay, I found it. So, God. User interfaces, aren't they wonderful? Okay, so with that, let's go ahead and open up the code for Atom Connect 4. Now, setting up to do things on the Atom, we actually are, Atom Connect 4 is actually building on two libraries that I put together to make software development on the Atom a lot easier. The first is EOSLib. Which gives you a C binding for every single function in the Atom elementary operating system. And this is important because we need a couple of these to implement talking to the FujiNet. And because the FujiNet on the Atom is an AtomNet device, you're using AtomNet functions to talk to it. So EOS read character device, which implements a blocking form of reading from a character device. And since the FujiNet network device is a character device, we use this function to talk to it. An interesting little tidbit for those that don't do coding on the Atom, input and output across the Atom net is entirely asynchronous. You place your command into the mailbox in memory for a particular device, and the Atom net controller will take and pick that information up, do the requested action, and then place an acknowledgement back in the mailbox when the request is completed, which is essentially what I'm doing here. We start the read and then we wait for it to finish, or we deal with it if something timed out. Simple enough. Same thing for writes. We won't go into that. The other is just a nice little screen library, which I call Smart Keys Lib. Which provides a whole host of functions to take and provide that nice blue screen that you see on the Atom. Did I close the camera on accident? Oh, of course I did. Okay. So providing the nice little bits of smart keys down here and the blue screen that everything else is built on top of. The rest is implemented entirely in Z88DK. The nice thing about Z88DK is that it's like CC65 on the 6502 side of things. It is a wonderful cross-target C compiler implementation with a lot of different targets. If you go to the Z88DK webpage, you'll see that it has support for something like 40 different targets, everything from the ZX Spectrum to the Coleco Atom to any CPM machine, whatever, you name it. If it has a Z80 in it, if it has an 8080 in it, it can create code for it and do so quite nicely. Since this was the most straightforward way for me to take and build something on the Atom here, and because we don't have bindings for something like some-basic yet, this is another area where I could really take and use some help. We can modify, I have the source code to some-basic, so we could actually take and add FujiNet commands into some-basic to make this nice and easy. But since I'm doing it here in C, this is what we have here. We have all the usual suspects for most of the game here. We have custom characters for game pieces, have little functions here for getting user input. And finally, we have FujiNet functions. And since this is an AtomNet device, we need to go ahead and find the device control block for it and set that aside. And you'll see that the commands are very similar to how they are on the Atari. We take and set up a little data structure here to send to write character device that corresponds to the command that we want to send, and the two auxiliary bytes, aux1 and aux2, for mode and translation, the URL that we want to send to connect to. We go ahead and fashion it out. And when we're ready, we take and we write out to EOS write character device. Now you'll see that we have a constant called net here. And we'll see that as of right now, net is defined as Atom net device 09. Well, that's all we have to do to essentially send a command out. And we go ahead and we wait to see if we're connected or not. Just retrying each time as we're not. we return the device, we return the same information that we get on the Atari inside of the device status on the AtomNet. So it works in exactly the same way. We can just check for the connected bit if we want to, return true. Otherwise, we just take and keep counting down until we are out of retries. Conversely, for listen, same thing again. We set up a structure. We use the same rules for creating a listening socket like we do on the Atari. And we write it out EOS here. Conversely, we check the device status here, see if we have a connection waiting. And that way we can act on it. Accepting a connection, much the same way, just like you saw on the Atari with XIO65, which is the capital A. We send the capital A here, set up the command functions exactly the same way here, write it out the character device, and so on. Same thing with send. We take, and the only major difference here is that because on the AtomNet, we already know how big each packet is because a length is sent as part of the packet. We don't need to send any of that or waste any auxiliary bytes for that. We can just say send a write, and the rest of the packet is what we want to write out to the device. Send it out. And anytime we want to receive something, all we have to do is just read from the character device, because anything that's going to come in is going to take and come in through the usual mode. Is going to come in as a receive packet. And then we take and process it a little bit, remove off the line feeds, etc. Make a nice clean C string that we can take and deal with. And that's really it, essentially. The rest of the code here deals entirely with drawing the game, doing the game logic, and making sure everything's okay. Getting the player names, connecting to the host, using the functions that we've defined above, or listening for the connection if we ask for it, accepting the connection when we have it, getting the host name, and finally sending the move to the other host. And you'll see right here, so long as we take and use the same protocol on both ends, so as long as both ends can understand what's going on the other side, it doesn't matter what language you use, it doesn't matter what environment you use. We can make cross-platform games very easily, and even more so when we actually start getting into taking and building multiplayer servers and the like, which will be a discussion topic coming up soon enough. So similar code from the basic here for dealing when the pieces are hovered. We take and send the moves across. Otherwise, if we're waiting for pieces to come in, we take and receive it, figure out what it is, deal with it appropriately. Getting the appropriate behavior for, depending on whose turn it is, using the right piece color, etc. So you'll see the majority of this just basically deals with the game logic. And the only thing that we have to do to turn this into a FujiNet game is just output the right telemetry at the right places and get the telemetry at the places where we need it to get it. So that's basically it for this particular section of it here. That wrapped up quite nicely under an hour here. Are there any other topics that you guys would like me to cover?
I have a question. So first of all, thank you so much, Tom. It's really, really awesome. When you have the connection to FujiNet PC via the Atari emulator. Is it planned or possible for the Atari 800 emulator on the Mac to directly connect to FujiNet PC?
The moment that somebody builds a custom device hook into Atari 800 that works like the one in Altera, yeah.
Okay.
So, you know, the moment that somebody rolls up their sleeves and does it, that would be, and you know, that's that'll be possible. So, you know, you know, there's lots of possibilities here. Let's see here. You can kind of see, and I think, as a matter of fact, I think one other thing that I should probably show here is another example. If we go to GitLab and we go to Bochano Bozanski's page, I can't speak. We can pull up his chestnut. Come here. Of course, the search box is right. Come on. Oh, come on. Don't do that to me. There we go. We can see here, for example, an example program that talks to an FICS server for playing chess. And the first thing that you'll notice here is that this is actually written in Pascal. And it works just fine, so long as you're talking the protocol that the FICS server can understand. So he devotes a good chunk of time here, a good chunk of code, to basically taking and processing each line as it comes in and only concerning himself with the lines that are interesting to him. But because of that, you have something that can log in and play chess quite well. So let's see if I can actually go into this. I will cold start. Come on. Ooh, Altera has frozen. Oop. Okay. Cancel. So let me do that again. Here, cold reset. No. There we go. Now we're going off-road, guys. We can go to FujiNet.pl all the way over in Poland here, and we can go to games, or let's see, is it going to be in games or networking? Let's see. I'm gonna guess it's not going to be here. So stop. There you are. We'll take and boot this sucker. So now we're connecting to freechess.org here. And I'm going to say, not a registered player, I'll just do guest. I forgot my user ID, but you can see that he's made a little chess program, a little chess client here. And here we go, parsing the board and so on. So we have a chess client that we can take and port over very quickly. We've got existing source code here, and this can be moved to other platforms very quickly. So it's a good example of a nice quick win to take and get FujiNet onto other platforms. Is there anything else that you guys would like me to take and cover? Because I will gladly do that.
Actually, I got a question.
Yeah.
I just checked over at Atari Mania. Didn't see any FujiNet games. Is there a repository for all the games? So that if people want to look at what it currently exists and then create a game that doesn't exist, or, you know, one-stop shop?
The current place that all this is actually happening right now, we have a repository on GitHub called FujiNet Apps, which is kind of slowly accumulating different things that we can work on. For example, here, Bill Kendrick's excellent ISS tracker is here on FujiNet Apps as well. The Connect 4 demonstration that you saw for both Atom and Atari is over here as well in its full glory. And I think this will be a good start to the place where we can actually start building various FujiNet apps that everybody can look at and try to do something better.
Sweet, thank you.
No problem.
I have a question regarding the binary streaming of data.
Yes.
Our idea was, instead of loading the data from the ATR file, we could stream game content like level maps or enemy positions in a binary mode.
Yes.
And it is wise to choose a proper moment, for example, when entering a door, or as it takes some time to stream even a small chunk of data.
Yes.
If we don't interrupt the main loop. So the question is, how do you think how big chunk of data we can transfer so it won't block or it won't be a very visible glitch in a game?
That is an interesting point. And I think for something like that, you want to actually use a very different approach. Now, if we look, for example, at the FujiNet programming guide, let me go back to it here. Yep. If we go back into the wiki here and go into SIO commands for devices, we will find, oh, it's not. Oh, it's not an N. It's actually a FujiNet. It's actually a FujiNet mode. You'll see here that there is a mode called Enter MIDI Maze mode. And what this essentially does, this was originally designed to support the game MIDI Maze. And it takes over the SIO bus completely and allows you to specify a particular, and puts the FujiNet into a streaming mode. So if you can write an SIO routine that can stream data across, you can make it as, it would be a good idea to keep the data, since the data is being sent as UDP packets, to be sent in 512 bytes or less per piece. But at least if you were to go into something like MIDI Maze mode here, you could get the data without the SIOV blocking the whole system in the process of sending or receiving the data, if that makes any sense.
Yeah, okay. So we'll do some tests.
Yes, this is something that we can experiment with. And this is also another thing too. The thing to really get across, that I really want to get across here. You'll see this particular repository here, FujiNet Platform IO, where the wiki is. That's where the main documentation is, but that's also where the firmware is. This is not an accident, fellas. I'm wanting you guys to take and come over here and look at the firmware to see what you could possibly take and extend, if that makes any sense whatsoever. You can see that the MIDI Maze mode, there's not much to it. we take and set up the UART as we need to, and then we just reflect packets to the next host in the list. That's it. Nice, simple and easy. So if there's something that needs to be added into the firmware to make everyone's lives easier, then I can add it, or anyone else can add it for that matter. That's the cool thing.
Tom, can you explain a little bit about what the MIDI maze protocol is? And because I know it was based on an actual device back in the day, right?
It was based on, well, it's essentially just raw MIDI protocol. The MIDI mate on the Atari 8-bit, it used the MIDI mate interface, and all the MIDI mate interface was, it just took the MIDI data that was coming in and sent it across the SIO bus. Now, because MIDI runs at a different baud rate that has a different clock rate than SIO can do. It runs at 31.25 kilobaud, which you can't quite do with the Atari's internal clock. It provides a clock signal that the Atari can sync to do that baud rate. The guys that did the Atari SIO protocol were forward thinking enough to think, oh, hey, wait, we can put a clock line on the on the SIO port so you can sync to an external clock other than our own. Very, very forward thinking there. But other than the constraints of just hooking the two serial buses together, there's nothing else going on other than you're just sending MIDI data. So from our side, from the firmware side, we don't care about that. All we're doing is taking the data that we see come in and reflecting it out to the next host over UDP. That's it. All the logic for that's inside MIDI maze itself.
I think it's worth to mention that SIO could has different speed. So basic and standard speed and high SIO.
Yes.
Also, right?
You can either have the SIO clock rate be generated by the Atari, which means basically that you can either have the SIO be generated by the Atari, which means that you can go from 0 to 127 kilobits per second, or you can have an external clock. Now, here's where things get a little bit more interesting. While the Atari can synthesize a clock speed that is approximately 127 kilobits per second maximum, so while the Atari can synthesize, okay, it looks like we got spammers.
Hey, I'm from some company, please end this meeting now.
Oh, good God. Hold on, I'm trying to.
Thomas,
yeah.
Mute all.
Yeah, where the hell? Okay. Where the hell is mute? Oh, there it is. Okay. Bam. Boom. Okay. Yeah, you gotta love it. It's mind blowing. So with external clock, the Pokey can actually synchronize to a clock speed roughly 4 times the 127 kilobits per second. The catch is writing code that uses few enough cycles to be able to receive that data. So you've got some you have some experimentation room. Okay. Looks like everybody's just moving. So moving forward, I guess since we're now being spammed all to hell. And since I guess the questions are pretty much done, unless anybody has any questions here, the only thing I would ask at this particular point in time, as we start moving on to other platforms, I want, if you're interested in helping, please help out in any capacity that you can, even if it's taking in, for example, you'll notice that there's not documentation for the Coleco Atom side of things. Try to help write documentation for the Coleco Atom side of things. As we start bringing up the Apple II, version, start trying to take and write documentation to bring up the Apple II side of things, and so on. See, now that we've got people that are spamming now, I have to take and I'm wanting people to speak up here. This is the irony here. Oh, fucking hell. Okay. Well, I guess since I'm pretty much done with my side of it here, I think we'll take and pretty much end it here. Is there, like I said, is there anything that anybody wants me to cover? I'll stay here as long as you guys want me to.
I think it was a pretty good presentation. Yeah, I don't know enough about programming Atari yet. I'm trying to get into it. And the networking part of it, especially FujiNet, is pretty exciting at this point. Really brings out new capabilities in old hardware, which is very interesting. So I really appreciate that.
No problem. Is there, would we like to take and start building some classes so I could take and start teaching some more basic programming bits for all of you guys? Would that be beneficial?
Yeah.
Okay.
It'd be beneficial to me. I'm a developer, so any language would be fine. But
right. Cool.
Yeah.
All right. So, all right. So with that, I want to thank all of you guys for coming. It's absolutely, it has been absolutely wonderful. And we will be doing more of these in the future, especially as we branch out to do other platforms. But here's the main thing, and this is something I want everybody to understand. Even as we branch off into other platforms, I'm going to set up these meets and these workshops as if they were one big thing for all platforms, because I want all of the different platforms that come under FujiNet to start working together, to start thinking together in different ways that we can make games, that we can make programs that allow all of the different retro computing platforms to take and come together in interesting ways. I want us all to start thinking as one. And I think that's going to be a very beneficial thing. And yes, Peter is putting the Discord links into the chat here so that you guys can stop by. I am constantly available for questions, to help. And I have a basic mantra. I have limited engineering cycles. But I will make infinite cycles to teach. That's a promise, and I hold that indefinitely. So with that, I think we're going to kill it here. Thank you guys so much for coming. It really warms my heart to see you all here. I appreciate it.
Thanks a lot for demoing. Really appreciate it. Thanks.
Wow.
Thank you.
Thank you.
Thanks, Tom.
No problem.